we have a design for our algorithm, we are going to move on to the implementation. So let's get started by opening hal.h. I already inserted here the prototype of the int_array_sort function. In hal.c, we are going to have actually the code, the definition of this function. And in test.c, we are going to add here a couple of tests to be able to make sure that the sorting algorithm is working. So let's get started with the coding for this video. Our ID relies on two different loops, okay, two nested loops, each with its own index. So I start by declaring the index, and then I'm going to put the structure of my loops. I is initialized with 0, I is lesser than, let's say, size for now, I++. And I say, let's say size for now, because when you program like that, you should be aware that the off-by-one bug with loops is a very common occurrence. So you have to pretty much like set the boundaries and revisit them later so that you make sure that you are not, forgetting something and ignoring, for example, the last element or something like that. For j, we are going to start at I+1, okay, systematically, because we want to start comparing data index I with all the elements of the data array that are coming after. So we start with the next one. There would be no point in comparing data index I with data index I to make a sorting. So j equal j+1, j lesser than size, and this will definitely have to be modified, and j++, not I++. Open curly brace, close curly brace, and I'm inside of the loop. What I need to do inside of the loop, compare. Compare what? Data index I. If it's lesser strict than data index j, or lesser equal, actually I have nothing to do. So I'm going to test, like I said in the algorithm, if it is greater than data index j. We are sorting ascending. If this is the case, curly braces, I'm going to swap the content of those two locations in the array. So int tmp equal data index a, data index j equal data index I think I just said A the line before, sorry about that. Data index I equal, let me catch up my logic here. I saved data index I should have overwritten data index I with data index j, and now data index j is going to be equal to tmp. We swap the content of the two location in that array. So we have a very rudimentary sorting algorithm, okay? We could like clean up the remaining bug by analyzing how it's working, okay? We could clean them up by running it by hand or making a trace on paper. I'm going to start here by just testing coding this sorting algorithm, okay? On one example, just to see how it is doing right now. So I'm going to save, go to test.c. Inside of test.c, well, I have already an array, right? So I'm going to call int array sort with my array, size 9. And then I'm going to call int array display with my array, size 9. Okay, so this is really not an exhaustive test suite here. It's just a matter of seeing if everything explodes when I try to run it for now, or if it compiles and execute semi-okay. And then we will test it exhaustively. Okay, so let's go back to Conqueror. GCC hal.c test.c. Compilation is fine. Now we run it. This is our initial array, okay, our initial test of the int array display function. Now let's enter something weird. 9, 8, 7, 1, 2, 3, 6, 5, 4. Okay, here's what we have. 9, 8, 7, 1, 2, 3, 6, 5, 4. This is the array I just entered. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the array once it's sorted. We're going to go back to the code real quick. What I would like you to work on, to think about, and post question if you're not quite sure. What are we doing here? We're iterating between 0 and lesser strict than size. So in my example, size was 9, right? So I is going to have value between 0 and 8. That means all the location in our array, okay? Now what is happening here? J equal I+1. So we don't compare that data index I to data index I. So we start with the right neighbor of our current location in the outer loop, and then we continue until j is lesser strict than size. Okay, try to think about this value here. Should we use size? Should we use size minus 1? And what is the difference in practice, okay, pragmatically? So you try to work on this one and post any question you have on the forum, and we are pretty much done with the code. The next step will be to try to actually test it more exhaustively to make sure it is working appropriately.